Good day, I'm Maile Matsiba. Welcome back to our channel. We're continuing today with our 2017 study guide of our CIR 113 module. We're looking at example 5.4.1. It says streams A, B, and C are mixed to produce stream D. Stream A is a 10% solution of H2SO4 and water, and stream B is a 30% solution of HNO3 in water. Stream C is pure water. The question is, what is the mass flow rate of C if it is required that stream D must contain 6% H2SO4 and 8% HNO3? The flow rate of A must be 160 kilograms per hour. So the question is, says, what is given the information, what is the flow rate of C? What must the flow rate of C be if D must contain 6% H2SO4 and 8% HNO3? So the very first thing is to actually choose a basis. And an easy basis to choose would be the 160 kilograms per hour of A. So we can just say 160 kilograms per hour of A, of stream A. Now with that said, we can just go to our step 1. So we can just say step 1. So since we know that A is 160 kilograms per hour and we are told that H2SO4 is actually 10%, we can actually calculate the H2SO4 in here. So we can just say calculate H2SO4 mass flow rate in A, right? So we can just say from A, therefore from A, we know H2SO4 is actually 10%, so we can just say H2SO4 is equals to 0.1, or 10% divided by 100% is 0.1 multiplied by the total of A, which is 160 kilograms per hour. And if you use a calculator, it gives you 16 kilograms per hour. Now we know that H2SO4 in here is actually 16 kilograms per hour. And now we're moving to our step 2. So let me just write here the step 2. Step 2. Remember, now that we know that H2SO4 is actually 16 kilograms per hour as we've calculated it, we could actually use that to calculate D, because we know that H2SO4 is a tie compound. All H2SO4 in A equals to the H2SO4 in D, and we have both the mass analysis of both A and D, so it shouldn't be a problem. We can just say calculate. Step 2 is calculate the flow rate of D. We're calculating the flow rate of D, our product C. So with that said, we can easily just say that we do an H2SO4 balance, like I explained. So we're actually going to do an H2SO4 balance. We know that if all the H2SO4 in here is equal to all the H2SO4 in there, we know that 0.1 by A, 0.1 multiplied by A is equals to 0.06 multiplied by D. This is actually our equation, so I can just name it as equation 1. So yeah, that's how it is. 0.1 of A equals to 0.06 of D. Therefore, with that said, our D equals to 0.1 multiplied by A all over 0.06, and is equals to 0.1 multiplied by, we already know our A to be 160 kilograms per hour, so we can just plug in that, and yeah, all over 0.06. Now this gives us a D of 266.6667 kilograms per hour. With that said, this actually telling us that our D our product stream is actually 266.6667 kilograms per hour. So we're done with our step 2. Now we can move forward to our step 3. Step 3. Now with step 3, remember now that we have our D, we can actually use HNO3 also as a tie compound, because we know all HNO3 in here is equal to all HNO3 in there. And remember, now we have the total, and we also have the mass analysis of HNO3 both in here and both in D and in B. So we can just say step 3, calculate the flow rate of B, right? So we're actually going to be calculating the flow rate of B, because we have the D and both the mass analysis of both HNO3. So we can just say HNO3 balance. We know for sure if it's 30%, so 0.3 multiplied by B equals to, indeed 0.08 is 8%, 0.08 multiplied by D. Therefore, our B equals to 0.08 multiplied by D all over 0.3 is equals to 0.08 multiplied by our D. We already know it to be 266.6667 kilograms per hour all over 0.3. And now when you use a calculator, that will give you a B of 71.1112 kilograms per hour. So that actually concludes our step 3. We now know the stream. Now it takes us to our step 4. Step 4. Remember, the question says, let me bring the question back. They say, what must the flow rate of C be if it is required that stream D must have these whole details? So the actual question is stream C, but stream C didn't have much of the information, so we kept on gathering more and more information until a point where we know that we are in a perfect position to actually calculate C. And that is now in our step 4. We're going to be calculating our C, which is actually the total flow rate of stream C. So let me say calculate the flow rate of stream C. Now, for us to calculate the flow rate of stream C, it's the easiest way is to actually make the mass balance of the whole system. Remember, A plus B plus C equals to D, and we have both A and B and D. Only C is not there. So we can just say mass balance of the whole system, right? You can just say A plus B plus C equals to D, right? Okay, let me just name this to be 2. Yeah, this we can just name it as 3. So A plus B plus C equals to D. Therefore, our C is equals to D minus A minus B is equals to our D. We know it to be 266.6667 kilograms per hour minus our A. We know that it's been a basis and it's 160 kilograms per hour minus our B. We just calculated it to be 71.1112 kilograms per hour. And now if you use a calculator, this gives us a B of 35.5555 kilograms per hour. This then means that this stream here is actually 35.555 kilograms per hour. So thank you for your time. That's actually the end of this question. Thank you for your time, and I hope we meet again in our next video.